Okay, so we're going to do problem number 5 from benchmark G.2.5. And the problem states the ratio of the perimeter of square RSTU is the perimeter of square WXYZ is 1 to 2. The area of square RSTU is 25 square inches. So part A, what is the area of square WXYZ? Part B, how many times larger is the square the area of square WXYZ than the area of square RSTU. So once again, we have our key terms on the left, ratio, perimeter, area, and square. And let's just underline those key terms that we see in the problem. So the ratio. So ratio, as we know, is defined as a relationship between two numbers or two quantities. Perimeter has been defined before as being the distance around a polygon. We also have the word square, which we know is a quadrilateral with 4 congruent sides. And we also have the word area, which we know is calculating the space within inside a figure, whether it's a polygon or circle. Okay, so let's do part A. So it says, what is the area of square WXYZ? So first, for part A, we're going to go ahead and draw out the figure. So we have first square RSTU. So let's go ahead and draw that out. RSTU. And it says here that RSTU is 25 square inches. So that is the area of this square. So if we know that this square, the area of square RSTU is 25 square inches, we need to find the area of WXYZ. But before we do, let's go back to what the question states, showing the ratio between the two. So we know the ratio is 1 to 2, meaning that we know that in this square, RSTU, WXYZ has to be 2 times as much as RSTU, stated here where it says 2 to 1. So before we do, we have to actually find out the sides of RSTU. So how would we do that? So let's go back to the area of a square. So going back to the area of a square, we can find that on our reference sheet. As stated before, it's under a parallelogram. Remember, a square has 2 pairs of parallel sides. So it is a parallelogram, so we can use the formula A equals BH. And in this problem, we do not have the sides. We only have the area. So in a square, if you remember, all sides are congruent. So that means that these sides are all equal. The measurement of all sides are equal. So that means that whatever the base is or whatever the height is, it has to be the same measurement. So we can rewrite our formula as A equals S squared. S represents the side, and because the sides are the same, we're squaring it. So if we know that our area is 25, and we're trying to find the sides, we're going to go ahead and solve for S. So if we have something that is squared, to undo a square, we take the square root. So if I take the square root on this side, I have to take the square root on this side as well. So my square root cancels out my square here, so we're just left with S. And if I have the square root of 25, I know it's 5. So my side of my square is 5. So now that I've found the sides of square RSTU, I can use that information to find out what the sides of WXYZ is. So I'm going to draw another picture here. And since my ratio states that it's 1 to 2, I know that my WXYZ is going to be twice as big as, or the sides are going to be twice as big as RSTU. So if RSTU's sides, square RSTU size is 5, and the ratio is 1 to 5. That means that however many sides, however much RSTU is sides is 5, it's going to be twice as big. So if you have 5 here, twice as big as 5 would be 10. So that means the sides here would be 10. And remember, this is also representing a square. So all of my sides are equal of WXYZ. So the question states, what is the area of the square? So if we go back to the definition of area of a square, that's taking the same formula that we used here, A equals BH or A equals S squared, and just plugging that in. So we have A equals BH, A equals 10 times 10. So 10 times 10 gives us 100. So that means that the area of square WXYZ is 100 inches squared. So that is our answer for part A. So part A, we know it's 100 inches squared. Okay, so let's move on to part B. So part B says, how many times larger is the area of square WXYZ than the area of square RSTU? So if we look at one key word or phrase, how many times larger? So how many times larger indicates an operation to me, either multiplication or division. So if I'm looking at RSTU, I know the area of that is 25 inches squared. If I look at WXYZ, I know that area is 100 inches squared. So how many times larger is WXYZ than the area of RSTU? I'm looking at the amount of area that I have here, which is 100 inches squared, and seeing what operation I can use. I can either use multiplication if I'm going from this one to this one, or I can use division. So since I'm going from here to this one, I'm going to use division. So I'm taking my 100 inches squared and dividing that by the area of RSTU, which is 25. So if I take 100 and divide that by 25, I get 4. So that means that WXYZ is 4 times as large as RSTU. Now if we wanted to move backwards, I could have said 25 times what number would give me 100? So 25 times what number? It's the same operation that we did here. We can multiply by 4 to get 100, or we can take 100 and divide that by 25. Either way, I get 4. So that tells me that RSTU is 4 times as small as WXYZ, or WXYZ is 4 times as large as RSTU. So either way, either operation that you decide to use, you would still come out with your answer as being 4. And that concludes for part A and part B of question number 5.